Now, I'm not sure if you knew this, but there are roughly 4.3 billion possible IP addresses, and we're out. Like, we don't have any more, which is a huge problem because, as you saw in our last video, if a device wants to communicate on the internet or with other devices, it needs an IP address. So in this video, I want to talk about how is that even possible, right? Because the people who invented the internet were pretty stinking smart. But you see, around the time they invented it, which the internet's birthday is officially January 1st, 1983, it seemed like the 4.3 billion supply of IP addresses was inexhaustible, right? I mean, it sounds like it might be. But they didn't understand two big things that honestly they probably couldn't see coming. The internet became kind of a big deal, obviously, right? And second, they did not anticipate all the devices that we would assign IP addresses to. I mean, think about it. They're like, oh yeah, maybe a few computers here and there. No, your watch, your oven, your microwave, your toilet. Now, because they did not understand these two things would happen, they did some pretty stinking dumb things. They mismanaged the heck out of our IP address space. So in this video, we're gonna explore that. What did they do? And later we'll talk about how we fixed it, kind of, with the Band-Aid. So by the end of this video, not only will you understand why the inventors of the internet were very terrible planners, you'll also understand a lot about IP addresses. We're building on the foundation that we set in the first video, and this video will prepare you to become a Master Chief Ninja, subnetting skill Master Chief Ninja. Because it is part of my series, You Suck at Subnetting, so make sure you catch all the episodes. Anyways, now real quick, can I show you something? Right back here. This guy right here. That little Raspberry Pi is running an entire business phone system. It's called 3CX, it's amazing, and it's a sponsor of today's video. Now you may remember me doing a video on setting up 3CX on a Raspberry Pi right here. I also did it in the cloud. Why? Not only was it an insanely fun project, but 3CX is an incredible phone system. And this is coming from a guy who worked with Cisco phone systems. Now you're probably wondering, Chuck, why would you put a phone system in your house? And I would say, well, first, why not? It's just cool. And second, 3CX makes it super easy because a lot of the features that you would be nickel and dimed for that cost so much are actually free. One of the biggest things is you have unlimited users on your phone system, which, trust me, is awesome. And also, as a small business owner myself, I use 3CX as my phone system for my business. I have a toll-free number in the cloud, I get free video conferencing, and my business is fully remote, and 3CX is built for that. Now, I also made another video, you can check it out right here, where I played with their live chat and I deployed it to my website. So right from my assistant's soft phone, she could take calls, take live video chats right from my website, which is kind of crazy. So if you're a nerd, for sure, try the on-premise install for 3CX or any other computer you have in your house. It's really fun, really nerdy. Why don't you want to have a phone system in your house? Doesn't everyone? And then of course, as a business, you can have this on-premise or put that sucker up in the cloud. Now check this out. You get 3CX free for a year. And not just the software. If you don't want to host this yourself, they will host it for you in their cloud for free for a year. So pretty much phone system for free for a year. That's what you're getting. So check them out, link below. 3CX is a phone system I run for my business and just as a nerd and a hobbyist. So check it out. Link below. So let's talk about how the inventors of the internet mismanaged and mishandled our 4.3 billion IP addresses. And if you want to get nerdy, it's actually 2 to the 32nd power, which is actually 4,294,967,296 IP addresses. But you know, 4.3 billion, close enough. So here's what they did, and it comes down to how they organized the IP addresses. They put them into what are called classes, A, B, C, D, E. Yeah, that's it. A, B, C, D, E. And there are two problems I have with this. First, there are large groups of IP addresses that we can't even use. I know, like why? You'll see. And second, they set it up to where they gave away too many IP addresses. Because again, they didn't expect the internet to take off and so many devices to have IP addresses, so they gave big companies just, hey, why don't you take 16 million IP addresses? Just take them. Well, we don't care. We have so many right now. We'll never run out. Idiots. Anyways, here's what they did. So you may recall from the first video that an IP address is 4 numbers separated by 3 dots. And each of these numbers can be anything between 0 and 255, which, using big brain math, will give you a total of, well, right up here. See the top, 4.3 billion IP addresses. But man, did they screw it up. So here's the classes. Here's how they organize these IP addresses. So here's the chart. Here's how we group them. I'm not gonna list every one of them off. That would be super boring. So just look at it. You can read. But seriously, if you're studying for an exam where you have to know subnetting and the classes, then you might want to make flashcards out of this and memorize it. Now, at first glance, there's nothing wrong with this. Actually, there is one big glaring problem with it between A and B. See if you can notice it. We'll talk about that here in a second. But the problem doesn't come in until this very weird thing they did. Here it comes. You ready? The subnet mask. Classes A, B, and C each have their own default subnet mask, which, if you recall from our last video, it determines basically how big the network is, or which numbers in our IP address stay the same and which ones change. For example, let's take the first network we have here. In class A, we have the 1.0.0.0 network. This is how it would look over here. Let's draw it out. There's the IP, and here is the subnet mask. If you remember the hack I talked about, when you see a 255 in the subnet mask, the corresponding or matched up octet, which is the first one here and the first one here, will stay the same. So 1 will always be in the IP address. And when you see a 0, anyone's game. It can be any number between 0 and 255. Now, that is a pretty stinking big network. Because if we're just keeping the first octet the same, the 1, but everything else can be different, do you know how many addresses that is? That is, I gotta look it up. Oh my goodness, 16,777,214 IP addresses in one network, which is insane, especially when you contrast that with your home network, which we talked about in the first video, might look like this. There's the IP address, and here's the subnet mask. And with 3255s, we're locking in those first 3 numbers, leaving the last one, the last octet, to be anything, which with this is a humble 256 addresses. So 256 versus 16 million, why? Well, the idea was that government entities or big companies might need a lot of IP addresses. And since they had plenty, 4.3 billion, let's just give them a whole bunch. And that's what the Class A was for. And you might recognize some of the companies that have these Class A IP address networks, like General Electric, GE. They own 3.0.0.0. IBM has 9. AT&T has 12. Xerox, 13. HP, 15. Each of these companies owns over 16 million IP addresses. So, looking back at our Class A range, Class A networks are very host heavy because they give you so many stinking hosts. Over 16 million. And thanks to their default subnet mask, there are only 126 total Class A networks. Now you're probably thinking, Chuck, are there actually networks like that big? Like 1.0.0.0 with 255.0.0.0 as a subnet mask? That's a lot of IP addresses in one network. And the answer is no, they don't really make them that big. Yes, the governing body who hands out IP addresses, the Santa Claus of IP addresses, or the head Oprah, we call them IANA, the Internet Assigned Numbers Authority. They will assign or allocate all those IP addresses, that entire network, to a company. We'll pick on IBM for a second with their 9 network. What they will do is take this huge network full of IP addresses and cut it up into smaller slices. So they might have the network 9.1.4.0 with a subnet mask of 255.255.255.0. And you're probably thinking, whoa, they can do that? Yeah. So while a Class A network has the default subnet mask of 255.0.0.0, that's the minimum they have to have. They can cut it up very small and say in this network, the 9, the 1, and the 4 will always be an IP address, and this particular network is smaller with 256 addresses. So they can take their big, massive network and turn it into smaller subnetworks. And that, my friends, is your first little glance into subnetting, which is what we're gonna really cover and dive deep into in the coming videos. Oh, and by the way, also, what we did here, taking a Class A network, and we cut it up and made it smaller with a different subnet mask other than its default. We call that a classless network. So for example, my home network is actually 10.7.1.0, a Class A IP address or a Class A network, but my subnet mask is 255.255.255.0, making it a degenerate, a classless network, because we're breaking all the rules. We're not obeying this A, B, C, D, E, F, G stuff. That's basically what you're doing. Got no class. But if you do obey the rules and you use the default subnet mask, then you're class full. You're full of class. You're elegant, but you're no fun. No, I'm just kidding. A little bit. So anyways, getting back to our address ranges, our classes. We focused a lot on Class A right here, and his subnet mask giving a network just a ton of IP addresses, too many. Way too many, which is, again, is part of the problem I have with IANA, or the head Oprah. They just gave away too many IP addresses. And then as we move down, you'll notice that Class B has a different default subnet mask of 255.255.0.0. So again, if we take this first network right here, bring it on down here, it might look like this with a subnet mask of 255.255.0.0. Locking in those first 2 numbers, those first 2 octets, those will always stay the same. But then these last 2 numbers, these last 2 octets can be anything they want between 0 and 255. I'm talking 65,534 hosts or IP addresses per network. So bummer, you get less IP addresses, which again is way too many, but the flip side is that you get more networks with a Class B. IANA, or Queen Oprah, can assign 16,382 networks, because again, a Class B, by default, must have a minimum of a subnet mask like this. And then moving on down the line, we got Class C, which will look the most familiar to you, right? Because it contains your home network. And again, we'll take that first network here, bring it on over here, come on little guy, with this default subnet mask. And those first 3 numbers, they're locked in. Can't touch those octets. And looking very familiar, we have a total of 254 available IP addresses on that network. This is the best plan. They should have done this with every single network because with Class C networks, we have a total available for Queen Oprah to assign 2,097,150 networks. So if they had done that with every class, we'd be okay. Kind of, maybe. No, we wouldn't. We have a different solution for that because eventually we would have run out. But we wouldn't have run out so quickly. Come on. Inventors of the internet, why can't you just look into the future and anticipate our needs? Seriously. So that's class A, B, and C. We're about to get to the D and E, which infuriate me. I mean, I don't get too angry about it, but it's still pretty stupid. But first, I just want to point out, and hope that you're picking up, that the job of the subnet mask is to help us determine how many networks and how many hosts we have for each class. Class C gives us the most networks and smaller hosts per network, whereas Class A gives us too many freaking hosts per network and like only 126 networks. If you stuck with the, classful subnetting or classful networks. But of course, and you probably assume this, nowadays, we mainly do classless networks to take advantage of the IP addresses we need to use. So anyways, I'm gonna officially say, Ayanna, that was a dumb idea. And now we're stuck with your mistake. But it's okay. All we have to worry about is learning this chart, memorizing it, knowing what it is, and then learning something scary called IPv6. We'll cover that later. So now let's talk about my biggest problem with this, is that there are IP addresses that we cannot use. We just can't. We can't. So Class D and E, notice they don't have a subnet mask because it doesn't matter. Class D IP addresses are reserved for multicast, or you might see it written in one word. I never know. All you have to know about those is that they're very important to networking and you can't use them right now. So don't worry about it. Just memorize what they are. And then Class E networks, these bad boys are mysterious. They are locked up in the Department of Mysteries, FBI, CIA, I don't know, they are experimental. So don't even think about touching those. Whew, you'll get in trouble. And I'm just kidding, you can't touch them. They're untouchable. Anyways, so we can't use D and E. And there's one more. I don't know if you noticed this. Look at that chart. Is there a number range missing? Can you find where's Waldo? I'll give you a hint. It's in between A and B. And also, here's the other hint, Dorothy, because there's no place like home. This will make sense. I promise it'll make sense here in a bit. I'm not losing my mind. You may have noticed that the range here ends at 126 and then picks back up in B at 128, making us go, huh, where the junk is 127? Like, where'd it go? That's a lot of IP addresses just missing. That's an entire Class A network, which means we're talking 127.0.0.0 with the subnet mask 255.0.0.0, which leaves missing over 16 million addresses. Where are you guys at? You know where they are? They're on your devices. These range of addresses, anything beginning with 127, are what's known as loopback addresses. You may have heard that term before. They're used for network testing. Now don't get me wrong, I love me a good loopback address because you can use it to test your network. You can actually make sure that your computer's networking is working by pinging your loopback address. What am I talking about? Let's try it real quick. If you're on Windows, go ahead and launch your command prompt or type in Windows key search CMD. It'll look like this. On Mac and Linux, it'll be terminal. And right here, stand across the board, type in PING or ping space 127.0.0.1. Now, if you're like, what the junk is ping? Ping is what we use in IT to see if something is alive and awake. So for example, I, on my computer, might send a ping message out to networkchuck.com saying, hey, are you awake? And if networkchuck.com is awake and alive and actually there and living, he should respond back with a response. It is by far the most common troubleshooting tool you'll ever use in IT. So looking back at our example here, we're gonna ping 127.0.0.1, which is an IP address that just is virtual and lives on your computer. And we should all get the same result if you're working. Hit enter. Hey, are you awake? Yes, I'm awake. Hey, are you awake? Yes, I'm awake. That's essentially what you're doing. You're just making sure that you can hear yourself. But the kicker is, and it's so stinking stupid. is there something I don't know about this? Here's the problem. I think all we needed was just this one IP address, 127.0.0.1, to test our NIC, our network, to make sure it's working, because we just did that. But for some reason, they thought we might need 16 million to do that. Because, do this. You can go ping 127.145.145.8. Just a random address, and we get the same thing. We're pinging ourselves. Our computer has 16 million virtual IP addresses ready to respond to itself. Why? Okay, it's okay, Chuck, it's okay. So, roughly 4.3 billion IP addresses, and we can't use a lot of them, and a lot of them were mismanaged. Thanks a lot, Ayanna. Thanks a lot, Head Oprah. No, it's fine. It's fun to learn this. It's fun to learn how our IP addresses were formed, how they're organized into classes A, B, C, D, E. And it's definitely something you want to commit to memory. So get those flashcards out. Memorize the sucker. It will come in handy your entire IT career, and also pretty handy on any kind of test you might be taking here soon. Now I know this might all seem like doom and gloom. I identified some problems that we have with our current IP address space and why we are just out. We're done. But don't worry, in the coming episode, I'll show you the massive band-aid we put on our IP address situation, and it did solve the problem. Kind of. And then we put an even bigger band-aid on it to really solve the problem, but who knows what will happen. I know, I'm not being specific, because I really want you to watch that video, so go ahead and watch it. It should be up here, somewhere. Or maybe up next over here, or over here. I never know where to point. Anyways, that's all I have. And also, have you hacked the YouTube algorithm today? Let's make sure you do. Hit that like button, subscribe button, and notification bell, and comment. Almost forgot. You gotta hack YouTube today. Ethically, of course. And yeah, that's all I have. I'll catch you guys next time. Now, real quick, in case you didn't know, this video is also part of my CCNA series, designed to help you and prepare you for the Cisco CCNA certification exam. That's a mouthful. And the sponsor of that entire series is Boson Software. So if you're looking at getting your CCNA, which you definitely should, it's one of the best IT certifications out there, check out Boson. They are, without a doubt, the gold standard in prepping you for that exam. From practice exams to lab software to courseware, they have everything you need to get the CCNA. And not just CCNA, we're talking CCNP, Linux Plus, Security Plus, they have it all. I personally use their lab software and practice exam software for the T-Shoot exam, which was part of the old CCNP, and it was super hard, but I felt so ready from using Boson. So if you're sitting here wondering, hey, man, I'm ready to take my Security Plus or my Linux Plus or my CCNA, but I'm not sure if I am ready. Take a Boson practice exam and they'll tell you. Odds are, if you can pass one of their exams, you could probably pass the real exam. So check them out, link below.